Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 5 of a unit motion in a straight line. So let us begin with today's class. In today's class we are going to discuss about the projectile motion. Basically this unit has been divided into three segments. First segment has been the vector that we have already completed. This is the second segment, it's a projectile motion. And in the third segment we are going to discuss about the relative velocity in the two dimensions. So first let's begin with the projectile motion and then we will move to the relative velocity. So let's begin with this projectile motion. What is it? So before we define projectile motion, let's have an example of projectile motion. Suppose a cricket ball has been thrown by a player. uh, I'm not talking about the rolling on the ground and something like this. I'm talking about the throwing, that one of the fielder was there and that fielder has thrown. He might be on the boundary positions and he has thrown the ball to the keeper or to the bowler. Let's take one more example. That's if you are playing a football and you are going to kick the ball and the ball is traveling in air. That are the examples of the projectile. So what we can say about the projectile is that it is a body which moves in a two-dimensional, please consider this, it's a two-dimensional plane in the gravitational field of the earth that we called as a projectile. I hope this is clear. It's a two-dimensional motion. Whatever we have done up till now, it is of one dimension motion. We are talking about the either my object was moving or running in the x direction, or either my object is moving or running in the y direction. Here it may be going to be move in the both the dimensions simultaneously at the same time. So it's a motion in a plane. Yes, so what we can say is a body which moves in a two-dimensional plane in the gravitational field of earth. It is moving under the effect of gravity, that we call as a projectile. I hope this is clear. Is it? So let's look at some more questions. Suppose an athlete is there and he or she is going to jump, let's say a long jump or a high jump. Even it is the case of a projectile. Let's say this is, look at this second case, that this is probably the fighter plane and it is going to launch some missile or bomb from it. So this is the case of the projectile. Look at this. If it has been launched at here, it is not moving in this direction but it is moving in this direction and it has been dropped at this position. Yes, though it is the a bomb dropped from an aeroplane flying at the same height. So these are the cases. These are the cases of projectile. One more very interesting. Yes, one more and very interesting. Look at this. First, look at this case. This is the a man has been fired from the cannon. In olden days, this was the case that to punish someone, they have been fired from the old. They are fired from the cannon. And look at this. This is very interesting. That if you see this, if you look at this, that a certain ball has been released. A certain ball has been released from the truck, and the motion of this ball is something like this. It is the projectile motion. I hope you understand this. Now I think you are clear with the projectile motions examples, that what exactly projectile motion may be. Yes, are you? Any questions? No? Let's move on. Yes. So whatever projectile motions we are going to learn, we are having a focus on these two projectiles. One would be the oblique projectile and another would be the horizontal projectile. Basically we are going to focus on this two. One is the oblique and the another is the horizontal projectile. Let's start and begin with the oblique projectile. A body is projected at an angle theta. This theta could not be 90 degree or could not be a 0 degree. Yes, a body projected at an angle theta horizontally and moving only under the influence of gravity, very important, is called an oblique projectile. It must be moving under the effect of the gravity only. So if it is the case that my object is there, it has been thrown with certain angle theta, but that theta cannot be a 0 degree or theta cannot be a 90 degree, then that motion, if it has been done under the effect of gravity, then that motion is considered as an oblique projectile. Yes, let's have a look how it look like. That suppose this is the origin from where I am going to launch, or I am going to project my an object. Yes, with certain angle theta. You can see here theta is less than 90 degree, even theta is not equals to 0. So suppose you have thrown this, suppose you have thrown this with velocity u while making an angle theta with the horizontal. So its curvature, its trajectory would be look like this, that it has been released from here and it is going to landed up at this position. Now I have marked certain very important terms. First thing, you must remember this all, that whatever the maximum horizontal distance, I am talking about the horizontal, let's look at this. Whatever the maximum amount of total horizontal distance that can be carried by an object, that we call as an range. This is the range. Yes, and it is going to be denoted by r. It is the maximum, this is the maximum horizontal distance covered by an object. This is the maximum horizontal distance covered by an object that we call as a range. Yes. Next, look at this. From here to here, it's a vertical distance. This is the vertical distance. This h is the maximum height of a projectile. This is the maximum height of a projectile that projectile has achieved in its trajectory. Yes. Now look at some other aspect of this also. That look at this. That I have thrown this with angle theta. Yes. So when we discuss the vectors, we have discussed the resolution of the vectors, that we can divide my vector into two of the rectangular components. One of the components would be the cos theta and another would be the sin theta. So I'm going to just divide the same thing. This is u and that has been divided into two segments. One is the u cos theta and another one, this is u sin theta. So what I can say is this is the horizontal direction's initial velocity and this is the vertical direction initial velocity. If I look at somewhere else, some arbitrary motion or some any other place, then I can have that this is the Vx and this is the Vi and this is the velocity V. It's a vector addition of this two, and here it is making an angle alpha. So if you are moving on next positions and let's say you have started your downward journey, then even in this position the things would be similarly. It's in Vx, this is velocity in y direction, so this is Vy and this velocity would be the V. I hope this is clear. This all are clear to you. Is it? Is it clear? Okay. Then let's move on to the next. What we considered is, let's just summarize this, whatever we have discussed up till now. That consider a body projected into air with an initial velocity u while making an angle theta with the horizontal. What we are doing is that we are going to resolve this two vectors. We are going to resolve this vector u into two of its rectangular components. Horizontal motion with zero acceleration. This is very important. My horizontal motion having no acceleration, and that velocity would be considered as ux is equals to u cos theta, remains constant throughout the journey. You must understand that as acceleration is 0, acceleration in x direction is 0, so force in the x direction must be equals to a 0, because you know that F is equals to m into a, and as acceleration would be a 0, force would be a 0. One more thing, a vertical motion is there with constant downward acceleration, this which is going to vary with time. So ay should be equals to minus of g. It's an vertical motion must be having an acceleration, and that acceleration would be effect of gravity only. If I consider upward direction as in positive, if I consider upward direction positive, then then downward direction is by default negative. So I have written here ay is equals to minus of g, and that is going to be changed. How? Let's look that. Suppose what we know is that let the projectile be at the point P of x comma y after time t, and x and y are the horizontal and vertical displacements after time t. Suppose a situation must be something like this, that we have done this. This is the u, this is the theta, and we are talking about certain arbitrary point. It's a, let's say P. This is x comma y. Here it is having a certain value of x, and this is the x-axis, this is the y-axis, certain value of y. So I'm talking about this. Yes, what I know is that I want to find out, let's say, horizontal displacement along horizontal direction. So horizontal displacement will be equals to, you know that speed is equals to distance by time. Here I am going to talking about the vx. That means I am going to talk about the speed in the horizontal direction, and that would be equals to u cos theta. So this x would be equals to u cos theta multiplied by time. And when I write x is equals to u cos theta multiplied by time, I am talking about the t is equals to x by u cos theta. Please remember this. We are going to use this in the next slides. Yes. What about the vertical direction? What would be the displacement along the vertical direction? Vertical direction, you know this, that y is equals to u of yt minus of half into g into t square. Do you remember this? Do you? Where did you use this? Yes, it's a motion in straight line relation. Y is equals to, we are discussing where at that position, that h is equals to ut minus half gt square. At that point of time, we are not going to discuss that whether it is in ux or it is in uy, because it is a one dimensional motion only. At a time, my particle was moving in either x direction or in y direction, but here I need to mention this because here my particle is moving in both the directions simultaneously. So let's write it down, that uy is equals to u sin theta into t minus of half into gt square. Now in the previous slide I have a relation that x is equals to u cos theta multiplied by t. So same way t could be written as x divided by u cos theta. So this is it. T is equals to x by u cos theta, and I'm just going to replace this, that this is t is equals to x divided by u cos theta. So this is y is equals to u sin theta multiplied by x divided by u cos theta minus of half into g into x by u cos theta whole square. So if I simplify this u and u would be a gone. This sin theta by cos theta, that is the tan theta multiplied by x minus of g multiplied by x square divided by u square cos square theta, and this 2 has been multiplied by here. So if I simply write this, this can be similar as y is equals to ax minus bx square. This is y is equals to ax minus bx square, and that a can be represented as tan theta and b can be represented as g divided by 2 u square cos square theta. Now this is also called as the equation of trajectory. I hope you understand what trajectory means. Yes, it is the shape that has been traced by a particle while in a motion. Yes, it is that we call as a trajectory of a particle in this motion. Okay, Now tell me what is the trajectory? Circle, ellipse, parabola, hyperbola. What is it? Yes, you were right. This is the trajectory. This is the trajectory of parabola. So my particle is moving while particle is moving in the parabola. This is parabola. This shape can be considered as a parabola. So this is the trajectory. Yes, the trajectory of a projectile is parabola. Have you seen it here? No? Okay, I purposefully left it blank. So this is the trajectory of a parabola. Please remember this. Please remember this. Yes, I hope you are clear with this. So in horizontal direction, it is an x is equals to u cos theta into t. In vertical direction, it can be written as u sin theta t into minus of half gt square. And if I required that I need a y as well as x simultaneously on a same relation, then I can use an equation of trajectory, which is y is equals to x tan theta minus of half gx square by u square cos square theta. What you are supposed to do is that please write down this relations while I am talking about this and while I am teaching this. Yes, because when and when we are going to use the numericals, you are needed with this equations. So please note down this at your book. Yes, so that can be easily referred in the next time. Let's look at some of the questions. First, what is it? Go through this. What this says is that body which moves in two-dimensional plane in the gravitational field of the earth is called as, what do we call, horizontal path, vertical path, hyperbola, projectile. Yes, this are not the case. It is the case of projectile that we know. Yes, if it is moving in two-dimensional plane in the gravitational field of the earth. Yes, that we call as a projectile. Great. Let's move to the next. Next, what is it? It is a body projected at an angle theta horizontally and moving. It is moving only under the influence of force of gravity that we call as an, what do we call? A body projected at an angle theta horizontally and moving only under the influence of force of gravity. What is it? Yes, that we call as an oblique projectile. I hope this is clear. Is it? Is it clear? Yes. So let's derive the two other remaining terms. It's a maximum height, range, and the time of flight. So let's first begin with the maximum height of a projectile. Yes. So when and we talk about the maximum height, the things would be something like this. This was the situation. This is u, this is the theta, and this distance is what we call as an hmax. So what hmax is, we can say it's a maximum vertical distance traveled by the projectile before its vertical component of velocity becomes zero is called the maximum height. Now look at this very carefully. At this point, it's an hmax. Here only one of the velocity would be there, and it is the velocity in x direction. Vx is equals to u cos theta. If I talk about the Vy at this position, if I talk about the Vy at maximum height, it would be n 0. So if someone asks me that what is the velocity at maximum height, if someone asks me what is the velocity at maximum height, then my answer should not be n 0. It should be an u cos theta, because what happens that we have been gone through the third unit, motion in a straight line, and at that time we were always discussing that at maximum height velocity would be 0. So that has been our practice, that if it is at maximum height my velocity should be 0, but here not is the case, because I am having a two velocities at the same time at the same position while talking about the motion in a plane. So here velocity in y direction will be for sure a 0, but velocity in x direction would be there, and that would be the total velocity when we talk about the maximum height. So it is in Vx is equals to u cos theta, and Vy would be a 0. So now let's derive this. What we know is initial velocity in y direction, it is a u sine theta. Final velocity in y direction, it is a 0. My acceleration in y direction, it is minus g, that we already talked about. And my distance traveled, that is what we call as an h. Now I know the relation v square minus of u square is equals to 2s. Let's replace this value. This final vy would be equals to 0. Initial velocity u square could be written as u square sine square theta, and this could be written as minus of 2gh. So if I solve this, it's a minus minus that has been plus, and this h can be written as u square sine square theta by 2g. Please write this. This h maximum height would be equals to u square sine square theta by 2g. Yes, have you done this? Have you? So let's move on to the next. Yes, these are the points, these are the key points that is to be remembered. Please remember this, because many questions are there which has been asked from this only. What they say is that the maximum height velocity of the projectile is u cos theta along the horizontal. Yes, 1 point. Next, at the maximum height the acceleration of the projectile body is equals to the acceleration due to gravity and which acts vertically downward direction. And the third, at the maximum height the angle between the velocity and acceleration of the projectile is 90 degrees, something like this. This is the direction of velocity and this is the direction of acceleration. So these two are aligned at 90 degree with each other. These two are aligned at 90 degree with each other. Is it clear? Is it clear? Yes. Yes. So I hope horizontal uh, h max is clear, maximum height is clear. And let's move to the next. It's a time of ascent of a projectile. It's what is time of ascent? Now we know that it is a time required to reach maximum height, that is called as the time of ascent, and the time of assault can be denoted as ta. And at the maximum height velocity along the vertical direction is 0, so we can write this as a vy, as the vy is equals to 0. And if I write this vy is equals to 0, I can say it's a t of a time of ascent could be written as u sine theta by g. Yes, it's in u sine theta by g. And what is time of flight? Time of flight, that we call as a total time that projectile takes to reach the same horizontal plane of projection, that we call as a time of flight. So this can be calculated by having a relation that y is equals to u sine theta t minus half gt square. Now, one of the very important point to be considered, let's look. This is y-axis, this is x-axis. I have thrown my projectile from this and it is going to reach at here. Yes. So let's look. This is its total journey, that thrown with the u and angle theta and all that stuff we know. So when it reached to the same horizontal plane, its displacement, I'm talking about the displacement, please note this, I'm talking about the displacement in y is 0. Yes, because it has been started in y dimensions from here and it has been ended on the same dimensions. So what I can have is, what I can write is that displacement in y direction is 0, and as displacement in y direction is 0, displacement in y direction is 0, what I can write is, it is a y is equals to u sine theta into t minus of half gt square, and this should be 0. If this should be 0, and if I equate this with 0, then I can write that it's a time of flight is equals to 2u sine theta divided by g. This t is equals to 2u sine theta by g. And if it is a 2u sine theta by g, what I can write is, it's a twice of the time of ascent. It is the same thing. It is the same thing that we did in the motion in one dimension. Yes. So this total time of flight we can write like this. It's a time of ascent plus time of descent. Time of ascent is u sine theta by g. Time of descent, it's in u sine theta by g. And total time, it's a total time of flight, it would be a 2u sine theta divided by g. I hope this is clear. Is it? Is it clear? Yes. Okay, let's move then
to the next very important point. It's an horizontal range of a projectile. In a very beginning slides, we have discussed that it is the range is the maximum horizontal distance traveled by the projectile from the point of projection during the time of flight is called as the horizontal range. Yes, it's a maximum horizontal distance traveled by the projectile from the point of projection during the time of flight that we call as an horizontal projectile. Now, along the horizontal direction, what I know is that initial velocity in x direction, it is u cos theta. Acceleration in x direction, it's in 0. Distance traveled, that is r. And time taken, that is t. So what I can write is that is the s is equals to ut plus half at square. And what I know is that r is equals to u cos theta into t. How did it arrive? I know that velocity is equals to distance by time. Velocity in x direction, it's in u cos theta. So what I can write is x is equals to u cos theta multiplied by time. Now it is the time of flight, so that's why t. And this x can be written as r because it is the maximum horizontal distance. So I have written this here that r is equals to u cos theta multiplied by time of flight. Is it clear? Is it clear? Yes. But what I know is the time of flight is equals to 2u sine theta by g. So let's replace the value. R is equals to u cos theta multiplied by 2u sine theta by g. So if I solve this, it's a 2 here. U multiplied by u, it's an u square multiplied by cos theta into sine theta by g. Let's rearrange this. Let's rearrange this and have a very important formula. It's in u square multiplied by 2 sine theta into cos theta divided by g. So if I write like this is a 2 sine theta cos theta can be written as sine 2 theta. Have you remember this? We have already discussed this formulas in the sessions of vectors. So this is sine 2 theta which can be written as 2 sine theta cos theta, and this is equals to u square sine 2 theta multiplied by g. Yes, our range is equals to u square sine 2 theta divided by g. Even even this can be written as that range is equals to ux, that means velocity in x direction multiplied by time of flight. Please remember this. This will help us to conquer a very good questions. It's velocity in x direction multiplied by time of flight. We are going to use it somewhere. Yes, but at this point of time you just remember this. So this is all about the range. So what, let's summarize that was, it's a formula list. The situation is something like this, that I am having a projectile that I have thrown with velocity u, and while making an angle theta. This is the range. It's a maximum horizontal distance traveled by an object. This is the h max. Yes. So let's begin. Let's begin first. It's a time of flight. You know the symbols now. It's a 2u sine theta by g. Second, it is the h max, and my h max is u square sine square theta divided by 2g. The third, it's in range. The range would be equals to u square sine 2 theta divided by g. Yes, this is the third formula. And next, equation of trajectory. Equation of trajectory fourth. It is the y is equals to x tan theta minus of half gx square divided by u square cos square theta. This is the list of the formula that you must have written in your book. If you have not, If you have not written this in your book, please I request you one more time that please write down this to your book, because these are the formula we are going to use from the next slide. So if you have not written, please pause this video, have a note of this all formula, and we are going to use this formula in the numericals. Yes, so let's begin then. Let's begin. The question is, a projectile is thrown with velocity of 30 meter per second while making an angle of 30 degree with the horizontal. Find out first H max, second range, next time of flight. At this point I require only this three, and I'm going to add something to this as well. But before I'm going to add something, we are going to just focus on this three. What the data is all about, that a projectile is there and it has been thrown with the velocity of 30 meter per second, and it has been make an angle of 30 degree with the horizontal. What I need to find out, I need to find out first is the H max. So let's have a rough sketch of it and work on this. It's an Y, it's an X, this is the projectile, and this would be the U, this would be the theta. Yes, I need to find out first it's an H max. What I need to find out, I need to find out it's an H max. H max can be written as U square sine square theta divided by 2g. So my velocity, my initial velocity was the 30, it's a 30 multiplied by 30 multiplied by sine square theta, it's a sine 30. Sine 30 is half, so this is half multiplied by half divided by 2 into g. Let's take it as a 10. Yes, so this is 10 3s are 30, and this is equals to 30 3s are 90. This is 90 divided by 8. This is 90 divided by 8. What is it? What is it? If I solve this, it's 45 by 4, and 45 by 4, it's an 11 fours are 44, so this could be written as 11.25 meter. I hope this is clear. Yes, this is the H max. Next what I require, it's a range. Next what I require is it's a range. Now range is U square sine 2 theta. This is not a square, it's a 2 theta divided by g. So my U square, my initial velocity is the 30, so it is a 30 multiplied by 30 multiplied by sine of, it is something like this, 2 into 30 degree divide by g, it's a 10. So if I solve this, it's a 3, 33s are 90 multiplied by sine 60, 2 into 30, it's a sine 60. Sine 60 is root 3 by 2, so it's simply 45 into root 3 meter. Is it clear? Is it? Are you sure? Are you done with this? Do you have a same answer? Great. Now let's work on the third part. It's a time of flight. Next they require is time of flight. What is it? So time of flight, that should be is equals to 2u sine theta divided by g. It is 2 multiplied by 30 multiplied by half divided by g. This 2 has gone. This 2 has gone, and time of flight is equals to 3 seconds. I hope these three things are clear to you. Is it? Is it? Is it clear to you? Yes. Is it clear? Yes. So shall I add something to this? Let's add it up. Next, what I require is time of ascent, and second, time of descent. Yes, I require time of ascent, I require time of descent. How could I find it out? How could I find it out? So, next, it's a time of ascent or descent. As I know, both are the same. It's a time of ascent or time of descent. This is TA or TD, that is U sine theta divided by G. So that would be a 30 into sine of 30, it's a half, divided by G, it's a 10. So this is 1.5 seconds. Yes, even you can write this time of ascent or time of descent, it is the half of the time of flight. This must be the half of the time of flight. So this is time of ascent or time of descent, that must be the half of the time of flight. Yes. Are you done with this? Are you done with this? Are you sure? Any issue? Any confusion? No? Are you done with this? So shall I add something? Shall I add something to this question? Yes. Shall I? So let's write it down what we require. What they say it is that in previous question, find out velocity of projectile at t is equals to 1 second. Yes, what they asked to find out velocity of a projectile, and when they require the velocity of projectile at t is equals to 1 second. So let's first have a sketch that what could be the situation and what they require and how can I calculate this, that this is the situation. Yes, this is the projectile have been thrown with an angle theta. Now if I have find out the time of ascent, and that has been 1.5 seconds. So it has taken total from here to here, it's in 1.5 seconds, and they are asking about the 1 second, so it must be somewhere here. So what are the velocities? What are the velocities at this point? So when we are talking about the projectile motion, we have already discussed every time that we must be having two velocities at the same time on a same position. One would be the Vx, the one would be the Vx, another would be the Vy, and the vector addition of this, would be the velocity V. I hope this is clear. So first thing is, how could I calculate the Vx and how could I calculate the Vy? So for Vx, to calculate the Vx, what I can do is, I know that Vx is equals to u cos theta, because acceleration in x direction would be a 0. So this would be, according to the data, u is the 30, cos theta, it's in cos of 30 degree. So this is equals to 30 multiplied by root of 3 by 2, and which will give me a 15 root of 3 meter per second. I hope this is clear. Now let's talk about the Vy. As I consider that what would be the situation in Vy is moving under the effect of gravity, and if it is moving under the effect of gravity, what I can have is it's in u sine theta minus of gt. This u would be a 30 multiplied by sine theta, it's in half, minus of g. G is the 10 multiplied by t, it's in 1. So if it is u sine theta minus of gt, this would be equals to 30 minus half, it's in 15 minus of 10, and that would be a 5 meter per second. Yes, so now I am having with the velocity in x direction, velocity in y direction. So, so what I require? I require velocity. I require an velocity. Yes, they are not talking about the velocity in x or velocity in y. They generally talked about the velocity. So when they use a generalized term that we require an velocity, that means they require a final resultant vector addition answer of the Vx and Vy. I hope you remember this. Yes. So what I can do is that my one of the vector is in this direction, it is in Vx. My another vector is in this direction, it's in Vy. And angle between these two vectors is 90 degree. So if it is an angle bit by a 90 degree, what I can write is V is equals to, this is the resulting velocity of these two vectors, could be written as Vx square plus Vy square plus 2 into Vx into Vy into cos of theta. Here theta is 90 degree, so cos 90 would be a 0 degree. So if cos 90 is 0, V should be is equals to root of Vx square plus Vy square. So value of an x, velocity in x, what is it? That Vx were the 15 root 3, it's a square of the 15 root 3. So this is 15 root of 3 whole square plus Vy where the 5, it's a 5 square. So this would be 15. If I make a square of 15, it's a 225 into 3, it's in 675. Yes, this is 225 and this is multiplied by 3, it's a 675 plus 25. So this is the root of 700. This is root of 700 meter per second. If you wish, you can write this as the 10 root of 7 meter per second. This is the final velocity. This is the final velocity. It is a 10 root 7 meter per second. Is it clear? Is it clear? Can you done with this? Are you sure? Can you obtain this results? Are you sure? Can you obtain this results? Can it be done? Are you sure, guys? Are you sure? Yes. So let's wind it up here. In this session, we were discussing about the projectile motion, but this is very basics. This is very basics of the projectile motion. We have just used the formulas and we have not used the any applications or any good applications up till now. So before you tune out to the next video, I request you that please go through this formula once again, and this will help you to understand the situation well. Yes, thank you. Have a good day. Take care.